It really came into its own in the 1920s and 30s when British life was transformed by what was known as the radio craze.
Once limited to naval ships, military communication, and research laboratories, radio receivers began entering ordinary homes in the early 1920s. Behind that transition stood factories producing something that had never been mass manufactured before: a precision electronic device built from wood, copper wire, hand-blown glass, and hundreds of individually soldered connections, assembled without a single printed circuit board in sight. Building one correctly was considerably more involved than listening to one ever suggested. This video will take you inside radio manufacturing in the 1920s to uncover exactly how wooden cabinets, copper coils, vacuum tubes, and hand-soldered connections were brought together into a working receiver, why each stage demanded a level of precision unusual for consumer goods of the period, and how an industry that barely existed in 1920 was producing millions of sets annually by the end of the decade. Right now, let us explore this remarkable manufacturing story together. Every radio manufactured in the 1920s began as an engineering design produced at drafting tables by engineers working from circuit theory that was still being actively refined and patented during the same period the products were being sold. The most common receiver designs of the early to mid-1920s were the crystal set, a passive device requiring no power source but capable of receiving only strong local signals, and the tuned radio frequency receiver, commonly abbreviated as TRF, which used multiple stages of vacuum tube amplification to receive weaker and more distant stations. Each design required engineers to specify every component before production could begin: the number and type of vacuum tubes, the inductance of each coil, the capacitance range of each tuning capacitor, and the resistance values throughout the circuit. Interestingly, the absence of standardized component values across manufacturers during this period meant that most 1920s radio designs were not interchangeable. A coil or capacitor from one manufacturer's circuit frequently could not be substituted into another's without affecting performance, adding complexity to both manufacturing and consumer repair that the industry would spend much of the decade working to resolve. From the drafting table, approved designs passed to the production floor where cabinet construction and component manufacturing began simultaneously. The wooden cabinet that gave each radio its distinctive presence in the home was produced through a sequence of woodworking operations that closely paralleled furniture manufacturing of the period. Walnut, oak, and mahogany were the primary cabinet timbers, selected for their dimensional stability, workability under hand and machine tools, and the quality of surface finish achievable through lacquering and polishing. Incoming timber was inspected for grain consistency and structural defects before being cut to the required dimensions. Cut panels were dried to a stable moisture content, then passed through planers and sanders to achieve the surface quality required for finishing. Cabinet sections were assembled using woodworking joints pulled under clamp pressure and allowed to cure before the next operation. On higher-grade models, decorative veneers were applied to exterior surfaces, followed by multiple coats of lacquer built up and sanded between applications, producing the deep gloss finish that made premium 1920s radio cabinets indistinguishable from fine furniture. Front panels, typically manufactured from bakelite or hard rubber compounds such as ebonite, were drilled to accept tuning controls, switches, and terminal connections. Engraved lettering identifying each control was filled with paint to ensure legibility. Completed cabinets and panels then moved to the component assembly area, where the electronic content would be built separately before the two halves were finally brought together. The coils used in 1920s, radio receivers were wound from enamel-insulated copper wire onto cylindrical forms, typically cardboard tubes, bakelite cylinders, or turned wooden formers, with the inductance value of each coil determined by the number of turns, the diameter of the form, and the spacing between adjacent windings. Coil winding was performed on dedicated machines that rotated the form while the operator guided the wire. But counting turns and maintaining consistent spacing required continuous operator attention throughout every winding run. A single winding error produced a coil that differed from specification, translating directly into a receiver that could not be accurately aligned to its intended frequency range. Each completed coil was verified for continuity and checked against reference samples before acceptance. Many TRF receivers of the early 1920s used plug-in coil sets rather than fixed coils, interchangeable units that users could swap to tune different frequency bands. Suppliers including National and Hammerlund produced standardized plug-in sets used across multiple manufacturers' designs, allowing users to modify their receivers for different frequency ranges, while giving manufacturers a way to standardize parts across product lines. Standard broadcast band receivers operated across approximately 550 to 1,500 kHz, and every coil had to be wound to tolerances tight enough to allow accurate alignment across that entire range after final assembly. Vacuum tubes were the most technically demanding component in any 1920s radio receiver. Many manufacturers purchased them from specialist suppliers, such as RCA and Cunningham, rather than producing them in-house, as tube manufacturing required glassworking equipment and process control that general radio assemblers did not maintain. Tube production began with the formation of the glass envelope, a precision-blown glass bulb of controlled dimensions. Inside each envelope, the electrode structure was assembled with considerable care. A heated filament, a fine wire mesh grid, and a surrounding metal plate were mounted onto a glass stem and held in precise alignment by thin support wires before being lowered into the envelope and sealed. Vacuum pumps evacuated the sealed bulb, removing nearly all of the air before the exhaust tube was melted closed. Each completed tube was tested for filament resistance and plate current before acceptance. Tubes failing specification were rejected, a commercially significant outcome, since tubes represented a large share of the total material cost of a finished receiver and were the component most likely to determine whether it performed to specification or fell short. Variable tuning capacitors were manufactured by stamping thin aluminum or brass plates to a consistent profile, then assembling alternate fixed and moving plates onto a common shaft with insulating spacers, maintaining precise gaps between them. As the tuning knob turned, the moving plates rotated between the fixed plates, changing the electrical characteristics of the circuit and allowing the receiver to select different broadcast stations. One of the most significant developments of the mid-1920s was the introduction of ganged capacitors, multi-section assemblies in which 2 or 3 separate capacitor units were mechanically coupled to a single shaft. Before ganged capacitors became available, most TRF receivers required users to adjust 2 or 3 separate tuning knobs simultaneously to receive a station, a procedure that frustrated consumers. Single knob tuning helped make radios easier to operate and contributed to wider consumer adoption of the TRF receiver in the second half of the decade. Transformers and chokes were wound from copper wire onto laminated iron cores, with turns ratios determining voltage transformation. Audio output transformers required careful winding to achieve the frequency response needed for acceptable voice and music reproduction. Once individually tested, all components moved directly to the chassis assembly stage. With all components produced and verified, assembly of the complete receiver began on the chassis, a flat wooden or metal base onto which every component was mounted in the layout specified by the circuit design. Tube sockets, coil mounts, capacitor assemblies, transformers, and terminal strips were secured with screws, their positions arranged to ensure reliable operation without unwanted interference between circuit stages. Hand wiring connected every component using individually cut and stripped wire lengths, carefully routed through the chassis and soldered at each termination point using handheld soldering irons and rosin core solder. There were no printed circuit boards in 1920s radio production. Every electrical connection was made by hand, inspected visually, and tested for continuity before the chassis was considered complete. A typical mid-1920s broadcast receiver contained several hundred individual solder joints, each one either correct or not, with no reliable way of knowing until the finished set was switched on and tested. At this stage, the completed chassis was united with its cabinet for the first time, controls connected to the front panel, and the assembly prepared for final alignment. Completed receivers were aligned on the production floor before leaving the factory. Each tuned circuit adjusted to the correct frequency using calibrated signal generators covering the broadcast band, ensuring the tuning dial corresponded accurately to the stations the receiver was built to receive. Following alignment, each set underwent a final operational test using a standard antenna and battery supply. Most domestic receivers of the early to mid-1920s operated from separate A batteries supplying filament current and B batteries supplying plate voltage. By the late 1920s, AC-powered radios became increasingly common as improved power supply designs replaced battery operation in many households, eliminating the recurring expense that had been one of the most significant practical objections to radio ownership. Sets passing final test were cleaned, packed with instruction booklets, antenna wire, and warranty documentation, and crated for shipment to retail distributors, department stores, and catalog operations, including Sears, whose mail order listings brought factory-built receivers to rural households beyond the reach of urban retail networks. By 1929, American manufacturers were producing approximately 4.4 million radio receivers annually, with the industry's total output value having grown from near zero at the start of the decade to approximately $411 million. Every one of those receivers had passed through the same sequence: designed, cabineted, wound, assembled, wired, aligned, and tested, before leaving the factory and entering homes where families gathered around polished wooden cabinets to hear distant voices for the first time, finding the world considerably smaller than it had seemed the day before.